Well, hello everyone, and welcome to this special live event brought to you by the B1M in partnership with IES. I'm Fred Mills, I'm the founder of the B1M, and I'm going to be your host for today. And I'm joined by some truly fantastic experts from across the built environment and energy solutions sectors, much to my relief. I'm very pleased that they're here with me. Bit of scene setting first of all, and just to give you a bit of context on some of the housekeeping bits. We're going to run for about an hour today. We're going to meet our panelists in just a moment. We're then going to hear a bit of scene setting from myself around digital twins and the University of Glasgow campus example, which we're going to be predominantly talking about today and using that to anchor our discussion with. We've then got some pre-prepared questions for our panel, just to give you guys some of the key points and make sure you get some of the most important messages out of today. But then we want to hear from you. We want to hear from as many of you as possible. So throughout this event, please get your questions coming into the Q&A section on Zoom. Now, depending on your device, it might be in a different place, but there's two features on Zoom. There's chat and there's Q&A. In the chat, tell us where you're from, say hello, share your thoughts, go for it. In the Q&A, just keep your questions, keep it to just questions in the Q&A and put them in that section. That would be much appreciated. And it will help us answer as many of your questions as we possibly can. If we don't get to every question, we're going to endeavour to answer as many of them as we can over email, or certainly pick up on the key themes. Now, unless you've been living under a rock for the past week, you'll know that today's live event between the B1M and IES is taking place against the backdrop of what is one of the most important conferences that's probably ever happened in human history. It's taking place in Glasgow, and it's called COP26. I don't think it's an overstatement to say that the decisions that are being taken there are going to influence all of our lives and the way that human beings impact this planet in the years and decades to come. So it's incredibly important. The built environment contributes to 40% of all greenhouse gas emissions. So once again, the world's most important industry, in my opinion, architecture, engineering and construction, has a huge role to play in reducing mankind's impact on this planet and helping us turn the tide on climate change. That's something that's incredibly important to me personally. It's really important to my two children. I know it matters to many of you watching today. So having set the stakes incredibly high and outlined the fact that our future survival basically depends on COP26 and going in building in a more sustainable way, let's meet our panel and start to ask them some questions about it. Today I'm joined by, as I said, a fantastic group of people. First of all, we have Ruth from IES. How are you doing, Ruth?
Hi, Fred. How are you?
Yeah, good, thanks. Can you tell us a bit more about your role at IES and kind of where you're coming from on today's subject area?
Yeah, no problem. So I'm the COO for IES. My own background is actually civil structural engineering, but moved into energy back in 2007 and then joined IES in 2011. And really what we're aiming to do in IES is to create new innovative technologies within the software world for helping all buildings across the built environment, from the single building, residential, through to commercial, industrial and entire cities, to basically decarbonize. So looking at how we can do that from better design, better operation, performance management, and just making sure that we can actually achieve the carbon emission reductions we set out to achieve in reality, and not just kind of as a paper exercise. So that's our goal.
Wow, that's quite a goal. That's a phenomenal introduction. I love the ambition. And we've also got Sarah joining us from the Centre for Digital Built Britain. How are you doing today, Sarah?
Yeah, very good. Thank you, Fred. Hello there, everyone. I'm Sarah Hayes. I work with the National Digital Twin Programme, which is all about developing an information management framework to enable us to share our data securely across organisations and sectors. And this is an information management framework which is being developed for all to use. So it's being developed collaboratively and openly. I also lead our climate resilience demonstrator project, Credo, which I'll talk a bit more about later. Today's been a very exciting day for us because we've launched a film and an app along the lines of our climate resilience demonstrator project. So I'll say a few more words about that later on. Thank you.
Fantastic, really looking forward to hearing it. And Gillian, you're joining us from the University of Glasgow and coming to us today from Glasgow.
Yes, I am. Hi, everybody. Thanks very much, Fred. Yes, so my name is Gillian Brown. I am the Energy Manager for the University of Glasgow. So we are but just a stone's throw from where everything is happening. So it's buzzing around the campus. We've got disruption at this moment in time, which is good to see, keeping us all on our toes. So our involvement with this project, the university, as you will hear, was to be used as a test bed for the evolution, I would say, of the digital twin, especially on a kind of large scale historic campus. So the project started off from our point as a research project, but my part in that, I would say, is really from an estates point of view, where we're looking to make sure that the research is one thing, so we understand what it can do, but to make sure that it's really practical, so that it actually can be used and rolled out through our own campus, but also other campuses throughout the UK and across the world. So really looking forward to kind of seeing how the whole sort of thing develops. And working collaboratively with IES to really get a great solution, not just for ourselves, but for everybody.
So we're looking forward to hearing more about it shortly. And Avi, you're joining us from SSE.
Yeah, thanks. My name's Avi, Avi Badia. I'm head of client development of a division of SSE that deals with distributed energy. My focus is the universities and higher education sector. And at SSE, as you know, we're one of the principal sponsors and partners at COP26, hence the logo in the background. But we come from a heritage of around about 50 to 70 years ago, where we started with hydroelectric power generation largely in Scotland, and we've evolved to becoming the largest renewable energy generator with onshore and offshore wind developments, some of which I'm sure you'll know. My goal in all of this is to help our sector, this education and higher education sector, to decarbonise on their net zero carbon journey, as we are doing ourselves. So, thanks very much.
Fantastic. So truly fantastic panel. And Esther, you're joining us from Mott MacDonald.
Yes, thank you very much, Fred. My name is Esther Gulacci, and I'm a technical director for sustainability and health buildings at Mott MacDonald, and I manage the climate resilience and ecosystem services team in our water unit. The company I represent, we are a major multidisciplinary engineering company, and we are involved with lots of initiatives regarding digital twins, and we are one of the partners in the National Digital Twin Project. Apologies. Via various colleagues of mine, and in my daily role, I tend to look at buildings and how they respond to climate resilience, how we can make buildings more resilient. But of course, the bigger picture in terms of how we plan our neighborhoods and cities is a very important part of climate change. And I'm very happy to be in this panel to explore how digital twins can facilitate that. The planning and laying out of our cities and neighborhoods for a climate resilient future.
Fantastic. Well, as you can see, guys, I wasn't just saying it. We've got a truly stellar panel today, some phenomenal minds from across the built environment and the energy solutions industries. Really looking forward to hearing from them in just a moment of time. Thanks again, guys, for being with us today. We really appreciate it. Now, this being a B1M event, there is, of course, a video attached. The whole essence and ethos of the B1M is to try and make construction more understandable and accessible to as many people as possible. And we're certainly doing that with IES on this project. So here's the key to net zero buildings is now up on YouTube. Go and have a look at that. It's also across our social media accounts. Kind of distills the University of Glasgow case study that we're talking about today and the potential of digital twins to make a difference, all in the context of the COP26 event that's currently taking place in Glasgow. So shameless plug for my own video, but do go and have a look at that because it makes it quite accessible and we hope quite shareable with colleagues. Now, as Gillian was mentioning, and as I've mentioned a few times, today's events and the case study that we're talking about is happening in extreme proximity to COP26. So this is where the University of Glasgow's main campus is. And you can see COP26 is happening down at the Scottish Events Centre down on the waterfront there. You've literally got every world leader, Greta Thunberg, David Attenborough, the royal family, Jeff Bezos, Wouldn't be surprised if you saw Beyonce down there as well. You know, it's everyone's there. The great and the good have all assembled. I wasn't invited; they must have missed my name off the list, but there you go. But this is how close we're talking. So, you know, the University of Glasgow campus is, I think it's even within part of the secure zone for this event. This is how close today's example is to where the action is at COP26. Now, what the University of Glasgow have done is well, they're going to explain it in more detail in just a moment, because they're the experts, but I'm going to try and put it in layman's terms for you. What they've effectively done is created a digital twin of a number of buildings across their campus. Now, what we mean by the term digital twin is essentially creating a digital replica of a physical asset, and then updating that digital replica with information from the physical asset that could come from sensors, reports, data and information that comes from the physical operation of the building, that goes into a digital model that would give you performance and analysis information on how that built asset is performing. The key to a digital twin is that it enables you to measure and understand with greater clarity how a physical built asset is actually being used, how it's performing, and the impact that it's having to its users. That's huge, because if you can measure the impact of something, you can then change and correct the impacts of it. And what's happening at Glasgow University is they're not just doing one building, they're doing a whole campus, and they're able to see their energy use, understand their energy use, and really work towards reducing energy consumption across their campuses, which reduces the carbon impact of our buildings. Now, if we can do that, not just on university campuses, but across a whole city, across the whole country, even between continents, we can make a huge impact on how our built environment impacts our planet, and we can reduce our impact on this planet. So what may seem a little bit dry, I'm conscious that the University of Glasgow's digital twin might not be the most exciting thing we've ever covered on the B1M. For me, it is incredibly exciting, because the potential that it has to make a difference to billions of people's lives on this planet is absolutely huge. Now, just to give you a bit of an example of how this works, this is the interface, the dashboard interface for some of the University of Glasgow estates. As you can see, it's incredibly intuitive. It makes data and information easily available to building users, whether that's the building owner or the users, people who use it every day, or even the general public in some instances. You can see there's kind of dashboard functionality. It can tell you, in real time almost, how many people are in the building, when it's going to be carbon neutral by, its energy usage. You can see incredibly easy to navigate around, incredibly intuitive. So this is the sort of thing we mean by digital twin, in terms of bringing to life and making clear to people how their buildings are actually performing. Because for a long time, it's not really been clear. We didn't really have an idea of how things were going. This is another example of making that data available, making it clearly accessible, understandable to people in a dashboard format. Again, this is the University of Glasgow campus. So you can see it's linking information from the physical asset to a digital environment, and then putting it in a format that is understandable and measurable to users and building owners. As I mentioned before, we don't want to just do this on the University of Glasgow campus. What's happening there is fantastic. But what we want to do is take what's happening on the University of Glasgow campus, where admittedly you have a number of buildings under the control of one organisation, and spread that out across a whole city, a city like Glasgow, and then in time spread that out across our whole planet. I know that might sound a bit over the top, but that's the ultimate value proposition of digital twins. If we could measure how every building is performing, if we can improve the performance of every building and learn from that data and feed that into how we build and develop future projects, we can seriously reduce our impact on this planet. So what may seem a bit of a dry case study is actually has huge potential for all of our lives, and is central. Diving back into Glasgow, as I said, the UN's Climate Change Conference, COP26, is happening right now in the Scottish Events Centre in Glasgow. I know that Joe, Greta, and Beyonce are probably watching this on their alias accounts, because they would never miss a B1M event. But if you are watching, guys, we need you to understand what's happening in the built environment, to understand the importance of the built environment, and to help really mandate and lead on this technology's adoption around the world. Because if we do this, we can make a big difference to the planet. As it happens, the Scottish Events Centre is actually a digital twin itself. So there is data, performance data around the usage of that building to help optimize its energy performance. That's a project that came about from SSE in partnership with IES. But yeah, quite ironic that the the event and the conversations that are happening around COP26 are happening within a building that's having its energy performance measured. So it's literally right under their noses. If they can heed the advice and help make this a standard worldwide, that'd be fantastic. Now we're going to bring the panel back in here because I've basically given you the layman's version of digital twins and their potential for our planet. But as you've seen from earlier, we actually have proper experts who know what they're talking about with us today. So we're gonna hear from them now. Just bring them up onto full screen so you can get more sight of them, which is always good. Ruth, coming to you first with a slightly huge question, but it's one I want to ask deliberately for people who maybe aren't up to speed with this. I've explained it a bit, but what do we really mean by the term digital twin?
Yeah, good question. And it's a good question in today's world because there's so many people talking about digital twins. And there's lots of different types of digital twin and different terminology around the digital twin. But I think the industry is now starting to adopt 3 terms for the digital twin. So the first is the project digital twin, and that's focused on kind of combining the information, the data, the documents, your 3D model, all into a single point of access for the information across that design, construction, and handover phase. So very much in the the design and the development of the building. The second then is the asset digital twin, which then focuses more on the operational phase and provides bi-directional links to sensors, actuators, collecting data from the real building. And then the third is the performance digital twin. And this focuses on the building and operation, and it also unlocks value from that asset and project digital twin. So IES are one of the few companies that have a performance digital twin that has physics-based principles embedded in it. And that's something that we kind of bring to the table. We combine those physics principles with data from the asset digital twin or from any sensors or data in the building. And as you alluded to earlier, that creates a 3D virtual replica of the building, which behaves like the real world counterparts at any moment in time. You can then use that, it's an accurate, reliable, virtual 3D model. You can optimize the performance in the building in real time. You can identify underperformance. You can predict faults. You can look at future interventions, different scenarios, what's possible to undertake within the building. And then you can look at that from an energy aspect, but also health and well-being, comfort, cost savings, looking at future decarbonisation planning. I think what's important with the digital twin and any digital twin is it can be used as a virtual testbed. So you have that virtual testbed for evaluating any proposed new building technologies or proposed operational interventions, and you can assess them before you deploy them. So, and the accuracy that the physics intelligence within IES that we bring, that gives you a high level of accuracy that you can de-risk that decision-making process of the different interventions that you might want to take and make sure that you achieve what you set out to achieve.
As I kind of alluded to earlier, the potential of that, if taken to its full scale, could be huge.
Yeah, I mean, essentially, with this technology, you have the ability to enable every building across the world to be decarbonised, but not only decarbonised, but do it accurately, cost effectively, and at a much lower capital cost than if you didn't utilise, the performance digital twins. And I think that's really key to kind of point out. We're trying to do this quickly, effectively, and at a lower capital cost than current kind of situations allow for. So yeah, the potential is absolutely massive.
I mean, I'm conscious this might feel quite new to much of the industry watching and maybe a little bit inaccessible. So getting into a real life case study, Gillian, what's the University of Glasgow been doing so far, and what have you found have been the biggest challenges of getting going and implementing digital twin technology?
Sure. I think probably creating a kind of, or sharing our experience as a case study really does make it very accessible for people, because it can be a bit hard. And I remember when the project came to the University of Glasgow, we partnered with IES and some other people. Even trying to convince our own internal people that it was a good idea was fairly tricky. I mean, these are some we're full of really, really intelligent people, so it's not a simple concept to get your head around. So as our part, we have provided the buildings, I would say, and give IES and the other partners in the project access to what it is, the information that we have. The first project or the first building that we picked was a brand new build, and we picked it purely because we knew that we would get some really good data. Obviously, the older the buildings get, the less metering there is, the less BMS points there are, the less lighting systems there are, the less sensors there are. So we tried to start the project on something that we thought would have some really great access to some really great data. Perhaps that didn't go as well as we had imagined. So we started then to look at some slightly older buildings, because we thought it might very well be that it's easy enough to do these on larger buildings that are brand new, because there's loads of information there. But I mean, anybody who knows, most of the buildings that we have just now are going to be buildings that we are going to still have by the time that people are getting to net zero sort of strategies and net zero end dates. So we have to look at some of these older buildings as well. And the university has a perfect example of a great mix of really old and some like 1960s, some 1800s buildings. So we've started to kind of look into some of those. I would say that the biggest challenge that has been so far has been with regards to data and getting access into data. We were amazed at systems that were open, and I'll put that in inverted commas, how unopen they actually seem to be. It has been very difficult. But also what we've found is that people within the university, as soon as you start to tell people what it is that you're doing, people have come to us with different ideas and different solutions and different bits of data that we would never have imagined. Strange things like our space timetable and people with whom we'd never really had a great sort of requirement for a relationship before, all of a sudden came up with some brilliant information for us. And the more we started to do this, do the Digital 20 project, get more people involved, spread the word, more people have come back to us with different streams of information that we're really starting to utilise. It has been tricky, I'm not going to lie. And obviously, brand new buildings are probably easier than really old buildings. But the value that we are getting as a university out of this is unbelievable. Historically, as a university, we've never really had particularly good detailed information internally, specifically within the buildings. We can tell you how much gets to the building, but after that, it always becomes very tricky. Things are wired differently from they were in the 60s and in the 1800s. Things are heated differently. And so this has really enabled us to be able to understand the buildings and do then things with that.
Absolutely. I think for those of you watching, you probably twigged that universities are kind of the perfect test bed, because you have, as Gillian was saying, a range of different building types spread out across almost like a city district type area, but all under the control of one organisation. So it makes kind of testing this stuff and rolling it out that little bit easier. I mean, Ruth, is that true? How's IES worked with the university so far? Has it been easier? Am I right in saying that?
Easy, as Gillian alluded to, it's like it's easy, and then there's you always meet hiccups along the way. But I think like it's been a very, very good project, and like what we've done so far on the campus is, you know, we looked at initially 5 of their existing, or 5 buildings, 4 existing, 1 new, and we've connected these 5 buildings to what we call a command center. So that's kind of what you showed earlier on, Fred, at the start of the video, but also a kind of a more detailed dashboard for Gillian, so that she can see information from all of those 5 buildings in one place. And then she can identify which buildings are underperforming or which need to take some intervention. So it's not meant to replace the BMS, because the BMS provides very valuable information about the campus, but it sits on top of the BMS and allows Gillian to optimize her time and where she spends it more effectively. And then through the Innovate UK funded project, which is, I named it stupidly, I can never pronounce it out loud, eDigit to Life. I'm not saying that again, it's now called the Innovate UK project. What we're doing there is we're creating innovative ways to provide what we call actionable intelligence. So that utilizes the digitized physics from the performance digital twin and that physics enabled technology. And what you can do now is you can optimize the building systems more effectively with that intelligence. I think just something else I kind of pull up on as well is that it's not just about, like, say, optimizing those hard systems in the buildings. It's also about other softer measures to help decarbonize. So, for example, like the screen you showed there with the screen in the JMS building on the campus, which is the new building, is actually a public facing dashboard. And one thing we've been looking at putting on that is to actually tell building occupants when they might need to tolerate a temperature for a short period of time. So what I mean there is, like, instead of, say, increasing the heating or the cooling load to bring a temperature back within a comfort boundary, you ask the occupants instead to tolerate that temperature, but utilizing the physics intelligence, you can tell them how long they need to tolerate it for. So in theory, by giving this information to occupants, it should lead to less complaints, you know, if they know they only have to tolerate this temperature for a short period of time. But that's the theory. So we're in the process of testing it and see, does it lead to less complaints? But I think the point is that like what you can do and what we're doing with the university is testing, you know, the opportunity to display the information, allow Gillian make better decisions, as well as optimizing the systems. And bear in mind that the university has a district heating system, which is also, you know, quite common, I suppose, with university campuses, but not common to a lot of other places. So you have to work within that constraint as well. But also looking at how do we encourage behavior change, or how do we enable the occupants to become active participants to ensure the building doesn't use more energy than it should. So it's a much more holistic approach, say, than just, you know, your standard BMS or what you might do with that.
See, that's the key thing, isn't it? It's about engaging occupants, because we can't just have this be done by facilities managers around the world. We need, you know, if we get the whole population involved, that's how you make a big difference. Absolutely. And now just quick shout out to the audience. We've got lots going on in the chat, but not really that much coming in the Q&A. If you've got a question, make sure you pop it in the Q&A section. We're going to come to those really shortly, and we'll get as many of them answered as we can. This recording will be available after the webinar, just to answer one of those really quickly. Esther, coming to you now. I know there's a kind of a holistic approach to infrastructure planning, and there's many different technologies that play a part in addressing the challenges of urbanization of societies and supporting the way we live. How do digital twins, in your mind, fit in with those other technology solutions that are being used?
Just to build on what Gillian was saying, it's very important to emphasize the role of existing buildings here, because when you try to plan out a neighborhood or a city, which doesn't happen often in the UK, but outside the UK, you can think about neighborhood planning, you know, plan out entirely new neighborhoods, precincts. And if you think about it, if in an urban area where there are lots of existing buildings, we found that in the UK as well, for example, that we're really good at designing new buildings and even constructing them. Handing over the operation is a different question, but generally we're really good at new buildings. We're much better at new buildings than we are at existing buildings. But if you look at the statistics, is only about 2% of the building stock in any 1 year is new, which means 98% is not. So, and what do you do with those? If you're trying to plan out something, you're trying to make a city more walkable, healthier, more equitable, you need to know what you're dealing with. And if you only have data for the existing or for the new buildings, but not so much the existing buildings, then you have an absolute patchwork of information where you kind of only know 2% of the information that you're looking for, where the new buildings are, assuming that the new buildings, the documentation and the digitization of those that information is perfect, which is far from the truth. So in terms of the way I see this as a professional, the potential for this is actually to generate a framework for information that then professionals who are city planners, engineers, architects, politicians even, to be able to use this information to make informed decisions about how to plan out precincts and neighborhoods. So, for example, when you look at what happened at the University of Glasgow, if you have a digital twin as an imperative, as a desired outcome, you will put those things in place to look at your data, to gather your data, to fill in the gaps, to put in metering, whatever you need to do to get that 3D working model, which right now for the majority of the buildings in the UK and probably around the world as well, we just do not have that information. So I see the digital twins being fundamentally about generating data and making that information available, and then being able to use that data to actually go to larger and larger scale. So the way that you alluded to it in the beginning, Fred, as well, is that you start with the building, you end up with the city, you end up with the world. And I think one of the questions is that then you can have data centers on the moon to power all that model, which is a very fair question, to be honest. But I think that's the key to this, that once you have these digital twins across larger and larger areas, the totality of the information becomes more than the sum of the parts, because then in come the softer aspects of social equity, healthy streets, like I mentioned, availability of food, for example. So you can come bring in all the other professionals that are involved in making a place, making a city, making a neighborhood, who can all feed into this much bigger model, which is not just a collection of digital twins, but all the other information that comes in from other disciplines, which are all necessary in order to come up with a final outcome, final neighborhood, a place that is healthy, livable, equitable. So tying those three parts, the economic, social, and environmental parts of the sustainability together into something that is an optimized whole, not just from a carbon point of view, but from the other aspects of sustainability as well.
Absolutely. I'm supposed to stay neutral as the moderator, but I emphatically agree with everything you've been saying. And as we know, Jeff Bezos is watching, so things on the moon might not be impossible in the years to come. Avi, I kind of want to bring you in here as well. How have you seen the world's approach to energy solutions change over the last few decades? How is digital twinning really playing a part in that, in your mind?
Wow, tough question. Last few decades. Well, I'm giving away my age here, but it's actually quite interesting because 25 years ago or so, I was living in America, based in the States, and working for an HVAC company, heating, ventilation, air conditioning company. My background is building services, and we were supplying a range of solutions to buildings and campuses and networks, which in those days, the key driver is energy efficiency. Still is today, but we kind of badge it differently, don't we? And in those days, the topic of the day was very much, as some of the previous experts have talked about, was the word open technologies. I was giving talks on behalf of ASHRAE and Lonmark about open building management systems and control networks versus proprietary ones. So just being able to connect disparate systems back in those days was a major challenge, I'd say. If you're asking me what was happening about 25 years ago, energy efficiency was still a driver, not labeled decarbonisation, but energy efficiency. But I think the biggest challenge back then was about connecting disparate physical hard systems and being able to share that data in order to do, as Ruth said, take knowledgeable action, if you like, on from this data, this information, being able to make those decisions. So that's been the case for a while. Where are we today, and how have we got there in terms of the world of digital twins? I think the imperative to decarbonize is the driving factor, right? We're all on the edge of the precipice of a horrific situation, and you cannot manage what you can't measure, right? So we're talking about systems back then 20 years ago about connecting the data. We've given that, we've gone past that discussion now, even though, as Gillian said, it's still a challenge to get the information that you want, and Ruth highlighted that too. However, we're now that the discussion is more about sort of, data tagging and what sort of nomenclature different systems are using, still to be able to share that data. So it really has changed a lot. But I guess that what I'm trying to say is the driving factor is more around decarbonisation versus energy efficiency, albeit energy efficiency is always the underlying driver here. That part hasn't changed. How we deal with it, how we deliver it is evolving. And I think digital twin is definitely the solution. We work very closely. I've been working for about a year now with IES on this strategy to develop digital twins, and we've done one together at the Scottish Events campus. And the owner of that campus there is facing the challenge that many of us, similar to Glasgow University and others, are facing. How do I decarbonize? So without the tools of a digital twin, you can't do optioneering. You can't model different types of systems. It's very costly to do those things, to make those calculations. Whereas the digital twin allows you to do those models, to see the impact of changes, to reach out to prospective in the new, the built environment for new construction, reach out to prospective tenants and say, look, you want to take this floor space, and sure, show us how you're going to fit this out and still maintain the building's, gold, platinum standard criteria. So the digital twin allows us to do that, and it's a fantastic tool. So
absolutely, yeah. No, I'd love to have a look at what the Events Centre digital twin is telling us this week. I know how much we I know how much kit we plug in on a B1M film shoot, so I imagine the world's media plugging in all their lights and stuff must be quite interesting.
But Fred, did that answer your question? I'm not sure.
No, it did. It was fantastic perspective of it. Yeah, no, honestly, really good, really good. Now, Sarah, I really want to bring you in because we're really pleased to have you with us today from the Centre for Digital Built Britain, and I really want to bring in your perspective on this because I know you have a more national view. You wrote Data for the Public Good, which recommended the development of the National Digital Twin and the creation of the Information Management Framework. What do you see as the benefits of those actions? What's the benefit of doing this nationally?
So the benefits are absolutely huge in terms of being able to share data across organisations and across sectors. So I think we're talking about reducing costs, reducing carbon impact, increasing resilience, and adapting to and being able to tackle climate change. We're talking about having all this information at our fingertips to be able to make decisions with respect to how to act now, how to tackle climate change, so that we really understand the consequences of our actions and interventions. And I think, imagine if we'd been using this technology in this way and collaborating in using this technology 30 years ago. Would we still be in the same position if we'd really understood the consequences of our actions back then? So, it really, when you're talking about the benefits, it really comes back to specific examples. You need case studies to demonstrate why we need to share data across organisations and why digital twins are actually helpful. So one example I can talk about is our climate resilience demonstrator project. What we're doing is we're creating a digital twin across energy, water and telecoms networks. And the reason for doing this is to be able to work out what happens if there's a terrible flood. So terrible flooding caused by climate change, what would be the impact on those infrastructure networks as a whole. So we can pretty much figure out what happens to individual networks, but what happens to that system. And you can only do that if you start to share data across those organizations, across energy, water and telecoms, so that you create a digital twin of the whole system and you understand the infrastructure interdependencies. So let's say there is a terrible flood, then being able to understand how that impacts the communications network. And of course, if communications go down, it makes it much harder to get the power network back up if an asset has been impacted by flooding. And so it's really understanding what the cascade of events is in the instance of a flood. So what we've been doing within the program, because there's a lot of technical work going on behind the scenes in terms of connecting this data across organizations in a scalable way. So what we're doing there is creating future best practice about how to connect data sets, because data is in all sorts of different formats. It's difficult to work with, and it's about how to get it into a clean format to connect it across organizations. That's a lot of technical work going on behind the scenes, but what we're also trying to do is tell a very public story about why we're doing this and how this will increase resilience across infrastructure networks. So we've developed a film which we've released today, tells a very hopefully a powerful story of why we need to do this, and also an app. So what I will do is I'll put those in the chat for people to look at later on. But I think looking at the film will really give you an idea of what the benefits are from doing this, which really aren't just financial.
Absolutely. I mean, and that's kind of leads on to my next question, because the key to this is uptake. We need it across almost every building and all of our existing building stock. In your mind, what's the challenge with that, and what do you think would be the thing that made a difference, or would it take? Is it case studies? Is it demonstrable examples? Is it energy bills rising?
Well, it's necessity, isn't it, that drives action. But a lot of this is about adoption and collaboration. So there's no point developing all this fancy tech and standards for sharing data if people aren't going to use them. So you need to involve people in developing standards and developing this technology and make it usable as you go. That is really important. Something that we try to do in the National Digital Twin Programme is bring in everyone. We talk about collaborate on the rules to compete on the game. We think it's really important for everyone to be able to collaborate in developing the set of standards so it works for everyone. And ultimately we see that the digital twin pie, you know, the market here will be much bigger because people can share data at lower cost more seamlessly across organizations and across sectors. But it's a lot about engagement really, and keeping people informed of what's going on and allowing them to develop it and shape it and contribute to this process, because it is all about collaboration. You know, we are using this technology to help us solve problems. It's not about here's the fancy tech, we want to use it. It's like we've got specific problems, we want to work together to solve those problems, and digital twin technology is then a means of solving those problems.
Absolutely. I think it's like with so many of construction technologies at the moment, it's about the value proposition and the outcome, not the technology and what it is and please use it, but the benefits at the end of the day. And if you get people on that, if they understand the why, then the how makes a lot more sense. So yeah, I completely agree. Now, guys, we've been overwhelmed with questions coming in since I've pointed you to the Q&A. It's somewhat exploded, which is great. We're going to try and answer as many of them as we can in the next what is now 19 minutes. Really good question coming first of all from James, and this I'm going to ask to Ruth if that's okay. What sort of data goes into digital twins? Is it meter readings? Is it live sensor data? Is it temperature, humidity? What's the kind of typical data that you might expect to find?
Yeah, from the IS digital twin aspect, it's both the physics data and the real data. And this probably, maybe I'll answer a few of the other questions because I saw them coming in as well. It's like, so on one side you have the physics model, which allows us to simulate the energy, heat and flow. So that includes information about your building, its envelope, its systems, the actual physics of the building itself. Then on the other hand, we also have information from the building and operations. That comes from data and sensors. So there's a question on, does it include unregulated loads? So the answer is yes, and that's very, very important, because every building, you have the building as an asset initially in the design phase. When the building actually is in use, it's very different. Then you have data rooms, server rooms, depending on the building, equipment, kitchens. So you have to collect information about how the building's actually been operated and collect data from that. So the more sensors you have, the more good information you have, the more you can couple that with the physics model and the better the accuracy you have for your model. So it's basically everything that you possibly can have. And then with respect to the accuracy, what you're doing is you're calibrating that to a performance standard. And there's a few out there, ASHRAE 14.0 or the IPMVP, allow you to actually calibrate it within a certain boundary using statistical methods. So you can actually, verify that your building is calibrated to the metered data and the energy use. And you do that at, another question that I think was on the chat as well, you're doing that at the zone level. You're not just doing that at the building level, but that you're doing that zone by zone. And we're actually starting to do that as well, not just for the energy data, but also for the things like temperature, relative humidity, CO2, so your indoor air quality aspects, you're calibrating to both. So you're really trying to make sure that your 3D digital twin performs very, very akin to how the building and operations actually performing.
Definitely. Now, a really interesting question that's come in from Catherine, which I think is kind of goes to the central debate around digital twins. And I kind of want to get everyone's thoughts on this. Who would you recommend holds the digital twin for an asset? Should it be the building owner? Should it move with the sale of a building? Should it be publicly available? Where do we begin with that, Esther? I'd like to start with you, if that's, unfortunately. What do you think?
Well, as an engineer, sort of having sort of a building services background, of course, I'm in favor of publicly available data, because as building services engineers, we've been harping on for much longer than I've been alive about the performance gap. And that goes back to the unregulated loads question as well, is that for way too long, we've looked at building regulations as one measure of energy performance, which has nothing to do with actually how the building performs. So the data being available is an excellent way to actually compare actual performance to calculated performance, and also gauge the effectiveness of building regulations around the world. So obviously, as an engineer, I would say that. On the other hand, I also see the tricky parts of that, because knowledge is power, and I'm not sure everybody around the world has that knowledge to know what to do with that data. So it's important that people who look at this data are aware of what they actually mean, and it's because energy performance itself, and in the bigger context of society and climate change, it's simply a very difficult subject, and it's a complex subject with various stakeholders. So So in terms of how you control this information and who has access to it and who doesn't, I don't have an answer to that, but I think it needs to be very carefully considered. Obviously, when you have the digital twin of the world and Jeff Bezos has the password to that, he will be very powerful. And that's something I think that's one extreme of it. But I think these kind of considerations of data security, manipulation of data needs to be very importantly, they're very important questions that need to be very carefully considered when deciding who owns this data, this information.
I completely agree. I mean, Sarah, what's your take on this from a kind of a national perspective? Are you able to have a view on this, or?
Yeah, sure, absolutely. Yeah, I mean, it's the question, isn't it? I think that, one of the questions is, why shouldn't this information be publicly available? So you kind of have to, we have often in the UK a tendency to commercial confidentiality, which, it's different cultures have different approaches to this. And I think it can help to sort of flip that on its head and say, well, why should this information be kept confidential? What are the benefits of sharing this information? Often the data holder won't realize the full benefits of sharing that data with other organizations. And, there's no reason why they shouldn't be able to realize value from it. But also I think it's being able to understand the full benefits of sharing it more widely. So I think that, there are often good reasons to keep data confidential. And I think when you create digital twins and you create means for sharing data, you want to work with the concept of role-based access, and authorized access. So you don't always want everyone to be able to access everything piece of information, especially about critical national infrastructure and certain buildings. So I think it will vary case by case. There is also the question about the quality of the data, and when it's publicly available, how that might impact the incentives of the data, the digital twin, the building owner themselves, to ensure the quality of the data. And of course, what you want to be able to develop over time, and this is the concept of the National Digital Twin Programme, is to encourage people to manage their information so that it is of a known quality, so that people can trust in it. Because of course, that's a really important element here. People need to be able to trust in the data that they are using.
Absolutely, you've answered my follow-up question as well about security, so that's perfect. Avi, what's your take? Who should own a digital twin?
Yeah, it's a really good question. Firstly, I think Catherine, the question is implicit of some challenges that we face, that the industry faces, both in two halves. I think you can treat like new construction projects one way and existing buildings another way. I mean, in terms of answering her question, in the existing building work, potentially it's quite simple, subject to the limitations that Sarah talked about and the information that that might be risk to security. Then why shouldn't that information? Well, the information should belong to the owner, right? The owner of the building. Very simple. As to whether when the building owner sells the building, potentially there's a limited subset of information that should come back into the public realm, perhaps like DEX or EPC certificates that we have today, but maybe a more vetted format of that data. So I think in the existing building world, that's a simple question to answer. Catherine highlights a problem in our new construction building in terms of the way we procure, the way buildings are built and designed and procured. There's often several parties involved, and there's a flow of information that is transferred over each mini project step, at each handover, and that in itself implies there are challenges as to who owns that and who should own that going forward. So one of the ideas that I've been toying around with IES, we've been working together in collaboration on this, and we've been approaching the new construction market with this concept of a living digital twin that as Ruth described earlier, has these three different phases, and those phases potentially could be owned by different players at different times in the construction process. So and as the REBA plan of work stage, if goes from 0 to 7, as that develops, the digital twin, this living digital asset, can exist in the public domain, but can be owned by the various parties who are involved at various stages, perhaps. And at the end of it, obviously, we get to what Ruth calls the performance digital twin, which then this is very much in the hands of the owner occupier, the user of the buildings, And this is where, you know, that particular user, or even if it's not the end user of the building, if it's the owner who's, you know, potentially looking to sell, you know, he has the ability to use the data to model different scenarios for different types of tenants, to remodel the spaces and to see the impact with using the real physics-based model. So it's a really, really good question, Catherine. Thanks for that. Definitely loaded in terms of your knowledge of the process. And as I said, I think there's two halves to the answer to your question. One would be a certain approach for existing buildings and existing owners, and then a second approach, more complicated, to the new construction process. And there's a lot of challenges there, but certainly with collaboration we can overcome them.
Absolutely, it'd be interesting around the sale of buildings if the value of property increases if it comes with a comprehensive, up-to-date digital twin. I've heard all sorts from estate agents over the years, but no one's sold me a digital twin with a property just yet. So,
and what's interesting, sorry, Fred. What's interesting is that in today's environment, right now, today, COP26, what better time is there to be driving the need for that asset, that digital asset, to go public with how we're going to decarbonize this building? As somebody said earlier on, you know, the majority of our stock is going to be around, the building stock today is going to be around in, you know, by 2050. If we don't know how to decarbonize that, we need tools like this to help us on that journey.
Completely
Sorry.
Agree. No, I completely agree. I mean, I just apologise to the audience if I've implied that I have a property portfolio. I do not, sadly, not at this stage. Now, a question I want to come to Gillian with. This is coming from Stephen. How difficult or easy is it to train people on using digital twins? Does it take much upskilling or educating?
I suppose it depends on the requirement that you have for digital twinning. Everybody has a different use for it. And I would say that depending on that use depends on how much information you need to know. So from my point of view, kind of looking after properties and looking after a large portfolio, I have taken a keen interest, so have learned quite a bit about how everything comes together. As it is kind of my role within the university to make these systems connect and talk to each other, I have a good understanding of that. But that doesn't necessarily mean to say that everybody has to have that level of understanding. The information that, or the pictures that you showed in the initial presentation, with the information that Ruth alluded to going publicly available, these people don't need to have a huge understanding of a digital twin and how it's all created. They just need snapshot information to allow them to make conscious decisions to act in perhaps a slightly different way or become tolerant for something. I very much believe that if people are interested and they want to learn more, it is a system that can be learned. It is nothing completely alien to people. Anybody who has dealt with modelling in the past, whether it be physics-based, BIM, anything like that, can understand this. And then the connecting of data, you don't have to be an IT whiz to understand how data systems connect together. You just have to understand the basic principles. I mean, we are using the digital twins that we've created for a number of different reasons. So for myself, obviously managing the buildings, for our estates teams who will take action based upon the outcomes from the digital twins themselves, they will have a different understanding of what is required. And then our facilities teams, also they'll make perhaps slightly lesser decisions or just different decisions, or understand how they can maybe change what it is that they are doing. Again, they don't need massive training in what actually takes place. And as I said, other people who just view the information don't need any training whatsoever.
So, I mean, Ruth, you've worked with a huge range of customers right across the built environment. What's your understanding of the uptake? Do people find it easy? Do people find it tricky? What's the average?
I think that pretty much, as Gillian said, depends on your level of knowledge. And I think that's what we're trying to do with different options. So it can be a case that if you're working, say, with the building owner and they don't have any engineering background or skill set, like, we create the digital twin for them. And then what we do is we give them services, because that's what the building owner wants. The building owner doesn't necessarily want the digital twin itself, but what they want to be able to do is perhaps track their ESGs, monitor their health and well-being, monitor their energy consumption, their carbon emissions, plan interventions, look at decarbonisation strategies. It's the services that the building owner wants. So we're creating that digital twin as the infrastructure for them, and then we're giving them those services. And that can be like on, you know, a dashboard that's customized for them, with their needs in place, and it's based on the level of their knowledge as well. So it can be very complicated or it can be very simple depending on who you're talking to. So, and I think that's the way we have to go forward, because if you're trying to deal with every building from simple residential or commercial buildings where you don't have technical users to now technical building owners. Like University of Glasgow is a great example where they're both a user and a customer. So they are the building owner, but they also want to use the tools and use the digital twin. There's probably less of them than there is your typical building owner that is non-technical. And that's a big shift we have to make, because like going back to what Esther was saying about the performance gap and everything else, like we've been doing this in the engineering world for a long time. We now have to create tools for non-technical building owners to be able to understand how their buildings are performing and what changes they can make, and how they can actually, like I said earlier, be active participants in the decarbonisation process, not just letting somebody else, solve the problem for them.
Absolutely, I completely agree. I mean, now we've had a really good question come in from Manus, but it's probably quite a good note to kind of end on, because I want to get each of your take on this. He's asking, as a structural engineer, where do I really start? Is it a case of sharing design information to a specific body? Do I need someone to help me create a digital twin? And I guess what I'd like to just go around and ask each of you is for those people watching today who are building owners, or perhaps work in the construction industry, or are perhaps consumers, homeowners, where should people start? What advice would you give to people starting out who, they want a digital twin, they've made that decision, but they don't quite know where to begin? If we can just kind of go around and get a bit of advice for people, that would be great. Maybe starting with Esther, if that's okay. So I'm picking you again first. I'm sorry.
No worries. I think some of it comes down to the basics of understanding how buildings operate. So a lot of times it's for existing buildings or residential settings, it's quite simple as, do you have a proper metering strategy? Do you have the data to begin with? So a lot of this, putting together a digital twin starts with knowledge about the buildings, because when you put a digital twin together, the questions come, about your fabric, about your HVAC system. So it's having that information essentially. And in a lot of cases, in residential settings, often that is missing, or it was never handed over. So a lot of this is finding out that basic information for existing buildings. For commercial and non-residential buildings, or when you're looking at new buildings, obviously there's a much bigger ecosystem of digital design services. So when you're talking about digital twins, when you're looking at new buildings and new construction types of projects, a lot of the design process is digitized already. And I think somebody was asking about links with Revit and things like that. So and from a structural engineering point of view, engineers have their own digital platforms, and the question is how you integrate this into a common language, essentially, so you can come up with a digital twin. So the solutions vary regarding as to who you are and what you're doing, but some of it is related to this kind of broader ecosystem of digital design and digital operations in new buildings. And for existing buildings and residential, it's about getting those basics right to begin with. And then the digital twin is almost the next step, because putting together the digital twin, you will come across those issues of having to produce that data to begin with.
Definitely. I mean, Sarah, in a few words, what would your advice be to people starting out?
Go and have a look at the Digital Twin Hub. On there, we have a toolkit exactly for this purpose. So anyone who wants to start developing a digital twin, it takes you through that journey, put together by a team of people from the community, actually. So it's people working across organisations who've been working in digital twins for a while. We pulled their knowledge and we produced this digital twin toolkit report, and it takes you through the steps on that journey. There's also a collaborative workshop tool that you can use. So I'd really recommend people go and have a look at that, because really it's about getting the right people involved from different teams. It isn't just about, oh, let's get the IT department or the data team involved. You really need, you need to get engagement across the whole organisation to get the most out of developing a digital twin.
Oh, fantastic. When I do go and look at that resource, guys, that sounds absolutely fantastic. I don't know if we get a link to that in the chat, that would be awesome. Gillian, you've done this before at Glasgow Uni. What would your advice be to someone else thinking of diving in?
the basics of understand what you know and what you don't know, I think, is probably the key, because you can start with almost anything. We were lucky we had some very basic models produced for something else, a completely different use. And so we were lucky that we had something to start with. But as everybody else probably here has already said, it is things like, what do you know about your building? And what do you know that you don't know? And can you find out that bit of information You don't have to start with everything straight away. You can build up, and I think that's the key. Don't be put off by the fact that maybe your metering's not brilliant, or your BMS doesn't speak to you, or your lighting control systems doesn't work, or you don't have a particularly good model. Start with something and then build into it. That's what we've been trying to do. We find new systems, we try and add them in. We find something else, we try and add it in. A new stream of data, we try and add it in. But we had to start somewhere, and I think that's the trick. Start at the very basics and just start at the bottom and work your way on.
Definitely. Ruth, what would you say?
Well, I think there's lots of answers to this question. I think from a basic building owner, measure and verify is the first step to any digital twin. And I think that's the first step to achieving any carbon emission reductions, is we have to measure and verify our building's performance. I think at an industry level, we need to work together. As Sarah said, interoperability is going to be key amongst any of this. Like Avi laid this out very nicely with respect to who owns the digital twin and all the processes, the stages across that REBA, process. Like all the industries across design, construction, commissioning, operation need to work together, or else we're not going to achieve this. And then, at the very top level, if you don't know where to start, contact sales@iesve.com and we'll certainly offer to help.
Fantastic answer. Avi, how about yourself? What advice would you give?
I'd say, as Gillian alluded to as well, you can't manage what you can't measure, right? So if you know what you don't know, go out and measure it, add it to your, become digitized. There's the cost of technology is becoming cheaper and cheaper now with IoT technology. Measure it, even if you don't know if it's important. Over time, you'll understand how that piece of data impacts your building and whether or not it is of importance. But without measuring it, you don't know that. You can't make that decision, if you like. So, most commercial buildings start with a building management system, and as Ruth said, sometimes the lighting is integrated, sometimes it isn't. Integrate them if it isn't already. Your metering and monitoring strategy, your AM&T meters, the fiscal meters, bring them into the system. Create this holistic platform of data, and then I think that's the first step, really, to build on towards digital twin.
Absolutely. I think that the quote about measuring is actually on the wall of the IES office, such as their determination and belief in this. So yeah, guys, we've run over very slightly. I could literally talk about this all day, but I'm not allowed to. I want to say a massive thank you to everyone that's tuned in today, and also to each of our panelists. We've been blown away with the quality of this panel. It's been fantastic to have each of you here. This webinar is going to be available on demand, so you can share this with your colleagues as well and get them to have a watch. And you can skip and rewind and go through all the details, which would be fantastic. Also, like a huge thank you for, as I said, everyone tuning in. This is an incredibly important subject at an incredibly important time, all happening against the backdrop of COP26, where I don't think it's an overstatement. There are some huge decisions being made about the future of this planet, and central to that is the conversation around our buildings and our built environment. So this technology is key. It couldn't be more important. As I said, massive thanks to everyone that's tuned in. Massive thanks to the panel. Huge thanks to IES for hosting and sponsoring us today. And we'll see you all soon. Thanks.